That's good. That's exactly what you got to do. So at least you're able to remember that and, figure out what you need and, right.
Yeah.
I know it helps to have the equations there too. It's not because,
Yeah.
might it'd be worse if you had to remember them. Okay,
Hmm.
so you want to just go through this guy here, go through the
Yeah,
problems.
I have a
Start.
quiz tomorrow,
Mhm.
and it's a problem like this. So I thought I would just like send you an example problem.
Okay, well, yeah, it seems pretty straightforward. Enemy target. That's good. You crossed off the 65-pound because that's not useful. We don't care about the weight. And
Yeah.
yeah, looking at that first sentence, you say, oh, I don't care about any of this information. Projectile is really the only thing that's useful, but you already know it's projectile motion. So good for us. So the Marines adjust their gun to an angle of 35 degrees. Angles are in theta. So that's the first thing we can write down, the known information, 35 degrees. I'm sharing, but I'm not. Let me see if I can do a little bit better. So, like I said, you can write that down. Let me get this last piece here. With respect to the ground, so again, that's that key piece here. So you can move on and say fire the projectile initial velocity and immediately move on and say, okay, initial velocity, good for me, 275 meters per second. Or you can, so that's what you can do because they give that information. Or the other thing, the other way to look at this is to say, okay, angle of 35 degrees with respect to the ground, stop there and start drawing your picture. It doesn't really matter which way you go here. But these are the two given things and you want a picture. This is the setup. Good so far?
So can you go over what respect to the ground means again?
Yes. So the horizontal, the x-axis, because this direction is up and then right up into the sky. Imagine looking out your window and they're shooting, like if you got a window, look out at it right now. And so up in the air is literally in the y direction. Towards the sky would be that y direction. You know, if you the
Mhm.
reason you look out the window is because it's 2 dimensions. Obviously we have 2 dimensions. We do not live in a 2-dimensional world, but when you look out the window you can view this. Here's your window and you can see, oh, this is up, right, the y direction. And then now look outside and maybe you can see the ground, maybe not, but to the right, to your right would be the positive x direction. And if there's a house in your way or whatever, you can visualize that there is ground out there somewhere, right, to your right.
Mhm.
Is that help at all? And let me
Yeah.
finish it up here. So if you're looking out your window and you can picture this thing that I'm drawing right here, or looking out your window and you look and you say, oh, there's an artillery gun. And it is, well, 35 degrees relative to the ground, relative to the x-axis, relative to the line out your window to the right. This positive x-axis to the right is always positive.
Mhm.
How's that? Does that help and clear it up for you a little, hopefully? Because
Yeah.
it's very important. So tell me if it's not, because it's okay if it's not. Oh,
And what makes sense?
you're good. Okay, sorry, I broke up there. Okay, great. So
Yeah.
always, well, just choose the positive x-axis to the right, and that's what to the ground means. It's relative to this positive x-axis. We talked about this a little bit before. Like you say, oh, but isn't this a ground? If you find the window and you say, oh, that must be 35 degrees. And you say no, because it's relative to that
Mhm.
line there. Okay, great. So then Yeah, that's all the information we're given. And an initial velocity. Let me go back. You can call this VI, put a little arrow to denote that they are shooting this thing in that direction. That's what that 35 degrees really means. It's a direction. Where? Well, 35 degrees relative to the ground, relative to the positive x-axis. If it was 0, you'd be pointing it directly along the ground, directly that way. It wouldn't be a projectile, right? It wouldn't be in the sky. So this is
Yeah.
the basic setup here for any projectile motion. And so for this one too, grab what you need. I think we've gone through it a lot and you seem good at it when I have you do the problems on your own. Grabbing the information, awesome. The picture is just as important for these types of problems. So hopefully that helps. There's again, practice is all you can do here. Okay, so we're asked for 5 things, which are all the standard things. If you go back to your list, velocities and distances and time, but those are the things, right? So you can even write that down. VIX. What is VIX? I'm asking you now. Like in words, tell me in words what this variable means, VIX.
That's like your starting velocity in the x direction.
That's exactly what it is. That's very perfect. And so then this, of course, I'm sorry, I should be sharing. Then VIY, of course, is, well, the initial velocity or the starting velocity. I don't care how you think about it, in the y direction or up, right? Like up, looking out your window, up in this direction. You got that, I think. And then, yeah, time is that's usually what we find. We found that together a lot in these homework problems. Time. How long does it take before it hits the ground? That's usually what we're trying to find. And then the total distance it travels in the y direction, the total distance it travels in the x direction. Let me verify. Well, obviously, when we get there, max height. So the maximum height. Right. Remember, one last thing you can do on your picture is say, what is the path of this thing? I know it's shot that way, but it doesn't go like that. Why? Because of gravity in the downward direction. And so the path of this thing is a forward curve, is what you call it, upside down parabola. This distance here, the max height, that distance on our coordinate plane is dy. So this is a little much for writing this down, because truly and honestly, you can just go to your equations and figure out what you need. But there may come a time where you do need to know, oh, dy, and like visualize it on your picture. It will help you. And just ignore it for right now if it's too much, you know what I mean? Because it's more important. You have what you need now to solve this. And then, of course, this is the distance it travels in the x direction, right? Oh my goodness.
Yeah.
Sorry, it's on my graph now. I just drew it. So that's what it looks like. Now, like we said, so let's do what you did first probably and what they asked for first. So VIX. And so just like always, figure out your stuff, figure out what you need. Then what is the equation that relates these guys? What particular guys? These 3. Why? Because we're looking for that. And the particular equation that relates them is VI, or the total initial velocity, cosine theta. So you can kind of do this at the same time, because VIY is the initial velocity. This is the initial velocity in the y direction. Let's not talk about that vector thing that we talked about quite a bit, but like these are components of the vector, but you just need to remember the equations for now and you'll be good. And then, well, plug these in. Let's do it together. I know it's on the paper, but might as well. It'd be 275 multiplied. Actually, you don't have to put the multiplication sign for your calculators. You shouldn't. Make sure you're in degrees. Cosine 35. I got 225.27 because this man is crazy and using 5 significant figures for some reason. If you go up, he's got 4 significant figures. So imagine that's important. The crazy guy, whatever. 225.3. What are the units, Julia?
Meters per second.
Yes.
Squared.
Remember, just velocity. So meters per second.
Oh,
Acce-
okay.
Acceleration is meters per second squared. Think of your basic,
And is that the only thing that's meters per second?
yes.
Okay.
Yeah. And just in case you say speed, how fast am I going? And just the most basic thing, how much distance do I cover in a certain amount of time? Distance divided by time. Meters is distance divided by seconds. Okay.
Okay.
So then, of course, VI sine theta would be again 275 times the sine of 35 degrees. Make sure your calculator's in degrees. Repeat, and redo, 157.7, I guess. I'm sure that's what you've written down. $225.27. Hooray, 157.7. Awesome. Now, those are the easy ones. I get to that point where they are like easy for you because it's just a trig relationship. We talked about it a little bit, but just the x is the cosine part, the y is the sine part. VI cosine theta.
Okay.
VIX rather. Okay, now time. Great. So you go to your third equation, I believe, on your equation sheet, and that should be, I don't know, square root of 2 dy maybe divided by a. Yeah, it must be. So, well, let's see. This is the one that I was telling you that you're going to have to. Okay, so that's a little confusing, but that's fine. Of course, you can use this one, right? What you have here is t times a is that difference in velocity. So I believe it's the fourth one. So let me say, you don't have to go in this order here. You don't have to find time right now. You could find something else. It's just, for this particular one, I believe it's the easiest way to go. But, you'll have a harder time solving it, but you can do it by solving for something else first. So I just want to say that. I think 4 or 5, the fourth or fifth equation on your equation sheet should be a, and then it's VYF minus VYI, 0t. And so that's what you have on your paper, and that's fine. And what you've done now is just solve this equation for t, right?
Mhm.
And hopefully you're okay with that. Let me know if you want to go through the steps, but this is the final. This is solving for t divided by a equals, great. So what do we have? Don't have that. Well, we didn't put it down yet. We just solved for that, right? That's there. This, what is that one? What's a?
Mhm.
Oh my God, I'm sorry. I need to get better at this. So here we are. Again, I was solving for it. Were you able to see that? Obviously not, right?
No, I didn't see that.
Okay, so it seems like you were okay with it, but remember, this is the fourth or fifth equation. That's all I was saying. And then I solve for t. We can go through it if you want, but this is that equation solved for t. Yeah?
Yes.
Good. Now we go in and say, oh, I want some numbers to calculate. Well, I'm not sure what that is yet. I know what that is. I just solved for it. And so what is a? I guess I was asking you, what is a here?
That's the acceleration, and that would be negative 9.8 meters per second squared.
Beautiful. This one, we just solved for it, like I said. Now the trick is we have 4 things, 1, 2, 3, 4, but we only have 2 numbers. You have to have 3 numbers, right? If you got 4 things, if you want to solve for something. And then you did this in class for sure.
Yeah.
Okay. Okay, fine. Well, it is 0 in this case. um,
Wait, VYF is 0?
yeah, well, that's what he has down. And if you did in class, so VYF is the final velocity in the y direction, right? Pointing down, the
Mhm.
component of velocity that points downwards along our axis, along our y-axis here, right?
Mhm.
So at the end of its flight, you figure the velocity is going to be, something like that. So there is a component in the y direction. You call it 0. If he's going to put the same thing, if this is going to be the same problem on the quiz, just call it 0 at the end.
So if it was a similar problem to this on the quiz, the VYF would be 0.
Yeah, because that's what he put. I don't, it's not, but if you did this in class for sure, and he put that, then maybe, so the only way you would assume that is if the object is stopped, right? And I guess you can kind of assume that, but
Mhm.
the reason, you don't need to know the reason why, because if it's gonna be on the quiz, it's gonna be this one. Yes, the answer to your question is yes. VYF will be 0. Okay.
Okay.
So that clears it up. And again, yeah, it doesn't matter. So that's why you get those things. Looks like you've done it, but you would do, 0 minus, so you don't need to put the 0, and then your negative signs cancel. So 157.7 divided by 9.8 is 16.09. Yeah, half of what you got there. Oh, did I forget a 2 or something? How come you have 32.2 on the time? Oh, there is a 2 there. Where did that come from? Are you sure you did this in class?
Yeah.
And there wasn't a substitute teacher or anything? Like he
No.
did this.
Mhm.
Okay. So then put your 2 on there. And like it's times 2. Oh. So times 2 on the equation here. It doesn't matter why. If this is going to be the same question, just do this. VYF will be 0. Multiply your equation by 2. And that'll get you 16.1. Okay, so that was, I don't know what's happening, to be quite honest, but why it is turning out this way. But we got the easy part. We got the easy part, which is the velocities right here. And then just go through this method to find the time. Once you have your VIY, you can use this equation, again, third or fourth on your thing. You know this value very well, minus 9.8. You consider that to be 0. And then whatever that number is.
Mhm.
Right? But don't forget to multiply by 2. So just throw a 2 on your equation there. So the equation you would use is VYF VYI divided by T, and throw a 2 out there. Okay. And solve for T like we just did. And that will and it won't matter if he realizes his mistakes later, because he's going to be like, oh, and everybody did it the same way, and he'll have to give you points anyway. So it won't matter. Just make sure you do it this way that he showed you. So again, 32.2 be seconds, right? Units in seconds. Now you can kind of easily do the rest of your stuff here. So what else do we need? You go back down to the bottom and you say, oh, dy. You have an equation for that. Again, like I was saying before, there's your 32.2 dy, the last two things, and then dy is the maximum height of this thing. And you say, okay, I have an equation. If you want to think about it, well, it's that maximum distance there. But your equation should be like 1/2. Is it this one? Is this on your equation sheet? Let me just look at this actually. Okay, so yeah, there's your dy. It's 1/2 a times t squared. And this is a very simple equation, but you have to have t, right? Remember one time we had to solve for the t before, like we just did, and then plug it in, because we don't need that, right? It's minus 9.8, easy money. So you got to use the absolute value here too for this one to get a positive value. Okay.
Okay.
Man, this guy is all over the place because now he's dividing by 2, like in the t here. You know what I mean?
Yeah.
When he's saying over here t is equal to this, you know. All right, I got to figure out the best way to help you. And so it looks like he, I don't know, realized his mistake or something. So, I mean, there's not, go back. There's not supposed to be a 2 here. Like, that's not right. But he has it in there. But then he takes it away later. Do you see that?
Yeah.
Are you sure? Because that's important. Because this is, I hate that this happened, because so it's already tough enough for you, and then this crap happens. So that 2, you can't see my mouse probably. The 2 on the T, actually you probably can. Can you see my mouse?
Yeah.
Yeah. So that 2 is not supposed to be there. Like I said, he threw it on because he was probably thinking about this equation, because when you solve for t, there's the square root of it. It doesn't matter. There's a 2 here for some reason, because this answer is actually just 157.7 divided by 9.8, which guess what is 32.2 divided by 2, 16.1, which is what he correctly puts over here. See, 32.2 divided by 2.
Mm-hmm.
So after going through all that, do not add the 2. Do not add this 2 when you solve for this equation. Okay.
Okay.
And you'll get it correct when you just do this, like we said here, where this is 0. He had that, and whatever, he let you guys do it, so you got to do that. You know what I'm saying? So 0, fine. Again, you solve for that from the sine theta. You know what that is. So the true time, which he does correctly have on that other equation, solving for dy, when he says 32.19 divided by 2, well, guess what? That is equal to 16.1. So then that's what you put in here. 16.1 squared times 9.8 divided by 2. Let me clean it up, actually. So we are finding the maximum height again, which is on your equation sheet, and it's written as 1/2 a, which in this case, we're going to use positive 9.8 times t squared. We calculated that previously. It's not 0.2, it's 0.1, and then you got to square that. Okay, so 16.1 squared, and I really hope I get 1269 for this, times 9.8 divided by 2. Great. So yeah, 1270, whatever, 1269 meters. That's the maximum height this thing has flown, as we know, because we shot it at an angle in the air with some initial velocity. We know it's going to come back down, and by that extension, we know that there's a maximum height if it comes back down. And that's what we just calculated here using that equation dy equals 1/2 a, where to just the acceleration due to gravity. So let me show you a trick. 9.8 again, right? Which you know very well, which is actually just 4.9 t squared. You don't even have to worry about a acceleration in truth. This is actually the equation. Sometimes a minus sign, sometimes not, depends on your problem. Okay, the last thing is dx. This is the same as your equation for r, but it doesn't matter. Forget I said that, because you already are given an equation for that, and you know that Vx, or the velocity in the x direction, is equal to the distance it travels in the x direction divided by time. Dx. For the same reason that this is always true. Speed, velocity, I don't care, is distance over time. And now we are just dealing with a component of velocity, the x component. So it's going to be the x direction, or the distance in the x direction. And then, as you did and hopefully can see very easily, it's just that, right? Which is not 32 point whatever, it's 16.1 times, I believe, 225, something like that, which should give you a 7251, I guess. That seems really big. So would he use the 32 again? That 2 shouldn't be there. What is this? Time of flight, the total time of flight. Why? Because that's the maximum height. This is the time maybe associated with the maximum height, so that's why you double it. Okay, so let me go back. I'm glad this is all you sure need to work on, but let me clean this up. Because looking at this now, what you have here is definitely correct. Now we go back. I'm sorry. So we did this one. There's nothing wrong with this. This is the easy part again. VI sine theta. We know that. You know it. There's nothing wrong with that. It was 225.716. What is this one? Switched 157.7, just like that. Okay, great. Now you can use this equation. Let's get in here, because this is not the final velocity at the end of the time. Projectile shoots up 35 degrees. Here's our initial velocity. Let me be a little better here, since I've already been confusing. X, Y, shoots up, VI. This is 35 degrees. What happens? It follows this trajectory, and it goes over here somehow. This thing is dy, the maximum height, the pinnacle, the peak, the zenith of its trajectory, the highest point. And so we use these values at that point. So we use that as our final velocity. Use this one as our initial velocity. And guess what? At the top of our time here, at the top of our projection, our trajectory, VF is equal to 0. I'm sorry, VFY is equal to 0. What does that mean? All the velocities in the x direction. There is none down, because it is motionless. It is not going up and it's not going down at this instant, right? If it's at the maximum, it's not going up and it's not going down for that split second, or literally instant of time. That's why it's 0. And so you go back here and you say, again, do your thing. This is all correct, of course, times it by time. So then when you get your equation for t, at this point here, it's not going up, it's not going down, right? T is equal to VYF minus VYI divided by A. Sorry about that. I hope that stops very soon. And again, at the top of the trajectory, this is our final point, the final velocity we're counting, not the final velocity here. We can choose any velocity, but it happens to be here. So that's why it's equal to 0.
Mm-hmm.
But you asked it before. Your question was, is on the quiz tomorrow, is VYF going to be equal to 0? And you say yes, but you have to remember that it's that point. Take this point here at the highest point. That's why. Okay, and then this is our VY thing that we had before. Nothing wrong with that. And this is, of course, 9.8, minus 9.8. Okay, you do multiply it by 2. So there's nothing wrong with what he did. So let me clarify that. I'm just an idiot and not paying attention or something. I'm not paying attention to these variables. It's very, you gotta pay attention to what these variables mean. It's the time of flight, not, it's the total time of flight. That's why you times it by 2, because I'm gonna share my thing again. I'm gonna try to explain this, and let me know if it needs more. This time is the time for it to go here to from the ground to the highest point.
Mm-hmm.
Right? That's how much time it takes. Why? Because we use this final velocity here. That's the only reason why. At what instant of time? Okay, good. But then, well, if it's at the highest point, that's half the trajectory. It's half the flight. And so it's going to take another 16.1 seconds to come back down and complete its thing. Since it's asking for the total time of flight, it's the only reason you want to do that at the end.
Okay.
So then you do get, of course, because we have it by 2 and it was minus 157.7 divided by minus 9.8. That's all well and good. That gets us 16.1. And again, that's this time here, but we want the total time of flight. So guess what? We got to multiply by 2 because that's the halfway point, thus getting 32. That's the total time of flight. Now, this is the key part here, why we're using different periods of time for each of these dy. This is the maximum height. So that's why you don't use 16.1. You do use the 16.1. You don't use the 32.2, which we calculated before as the time of flight. Like this is the true T that they're asking for, as you can see on your paper.
So, for the dy, you use the 16?
Yes. Because that's how much time it took to get to its maximum point that we just talked about, halfway through its motion right there.
Okay.
Which is why he has the 32.2 divided by 2. Because it's not the total time. We want half of that total time. So half of 32.2.
Okay.
And then you go in here again. For the dx, it's that velocity in the x direction. That's your equation. You say, oh, this, I know what that is. That never changes throughout the path. That never changes. It's whatever we said, 225.7. And then you say, what is t? Oh, it's 16.1. And that's wrong. Why? Because the 16.1, if this is our thing, that's not too bad, actually. So this is dy, which we calculated before. It takes 16.1 seconds to get to here.
Mm-hmm.
But then it takes twice that to come back down and complete dx, the distance in the x direction. So that's why dx is equal to 225.7 times 32.2.
Okay.
So hopefully moral of the story is pay attention to what time, what instant of time. That's a rookie mistake, and I just made it, so you can see how easy it is. So be very careful, right? You got to know exactly which time, because there's technically 2 times here, and he made it easy on you by saying, oh, we're just going to call this maximum point in the trajectory. See that dy, that thing, that same thing, that's the time it takes to get from here to here, which is half of the time for it to get all from here to here, right? And the only reason is because
Yeah.
it's at the maximum point.
Okay.
So that's all we got. I'm glad we got that cleared up. If you want to go through it with me, you know, say it out loud, because we got another 10 minutes here. And this we covered the whole thing. Or if you want me to go through it again now that I have it correctly, to show you the process again, just let me know what you want to do.
Can we do a different problem, but go through it?
Yes, that's a great idea. Okay, so let's say that then. What are we given? That stuff. Okay. I'll use some easier numbers here also. So let's say the extract, okay. They're going to give you something. Looks like he's going to give you an angle ray. Let's say it's 60 degrees. And let's say our initial velocity is 100 meters per second. I won't waste time writing a question out and all that stuff, because that's what he gave you before. That's what we're going to have. Just pretend it's the artillery. You get it. So then draw the picture. What does the picture look like? Okay, well, it's this. Up is in the Y direction. To the right is in the X direction. Imagine looking out your window and you see this artillery shooting up. Luckily, it's not pointing at you. And you can draw it and say it's relative to the ground. Does that mean relative to the positive x-axis? That's why it's to the right. So 60 degrees. And there's going to be some initial velocity.
Okay.
Tell me if you want me to slow down, actually, too, because I realize I'm going a little fast, maybe. So this is the basic thing. This is the setup. Nothing's been done yet. Now, okay, we set it up and now we fired the thing. We know the initial velocity and the angle. What's going to happen? It's going to be a projectile. What does that mean? It's going to go like this. It's going to go up, and then there's going to be a highest point, very important point, and then it's and then it's going to come back down.
Okay.
So then this is what you label after that. Draw your path. Obviously, look at my path. It's not perfect, but it gets the point across. And then label this thing dy, and say to yourself, what is dy? It is the highest point in the trajectory, right? It's the maximum point, which you keep in mind that it takes the time half to get here, half of the time of the total time, half of total time to get to dy, which is what? The highest point, of course.
Okay.
And then this thing here is dx. What is that? The total distance it travels in its path, the total horizontal distance, or the range. How far does this thing go? Throw your football. Where does it land? And you measure that distance between your feet and the ball once it's, lands. That's what the dx is. So the first part and the easiest part kind of is, well, what are the components of our velocity? What is the velocity in the initial velocity in the x direction? Well, it's this equation. Also, what is the initial velocity in the y direction?
Vi sin
Yes.
theta.
Are you good with your trig, your unit circle? Good enough, at least?
Yeah.
Write these down. Yeah. So let me make sure. Cosine 60, yeah, that's 1/2. So this would be 50, and this would be 50 square root 3. Just in case. Yes, good. 1/2. Okay. So that's great. And then we did that. And that's obviously what they asked for. And great for us. And oh, and a little mental note for yourself is this never changes. It's always 50 degrees, 50 meters per second throughout the path, always and forever. It never changes because there's no acceleration in the x direction. That 9.8 only operates in the y direction. Okay, so then you say to yourself, oh, what do I need now? Well, time would make sense. So then you say, okay, the time of flight, the total time of flight. And this is where it gets tricky. Grab your equation, this equation, I believe, whatever it is, 4 or 5 on your sheet. You say, okay, well, this is going to help. But this is where you have to be really careful and look at your picture and know what you're doing. Why? Because you have to choose this and this very carefully. So we're going to choose this one, the initial velocity, to be right here. Only then can you use that number. Okay. And then we choose the final velocity up here, that blue mark up there. Not down here, as I made that rookie mistake, right? The highest point. And the only reason it matters, then we can say, oh, right, it's at its highest point. At the highest point, it's not moving up or down. It's literally only going to the right. Well, then the initial the velocity in the y direction, that final number should be 0. Makes our life easy.
Okay.
So then let's I'll be real explicit for you here. So VYF minus VYI divided by T. Well, solve for T. Yes, for all the reasons we just talked about, this is 0. That's where you have to be very careful. And use that point there and say, oh, it's 0. Whatever that number is, 50 root 3 divided by, well, it's minus 50 root 3 minus 9.8. So if you want to do it real quick so we can verify. Got 8.84 seconds. Now the difficulty is not done because you can't just say this because they're asking for the time of flight and you say, oh, done. No, time of flight is this entire thing here. What did we just calculate? Half, right? Only half. Why? Because we chose that point to make our equation easier. But now that's when you do bring in the 2, you say times 2.
Okay.
So that'll be that, whatever that is, 17.9 or whatever, 2.8 for 17.68. Should have been able to do that. You would have seconds for the time of the total flight. Okay, then what is the maximum height? This is where you have to be careful about which t you calculated earlier you're going to use, because you're going to want dy. Well, you know the equation, but the only tricky part is which t do I use? And so you want to use your final value divided by 2, or this one. If you feel more comfortable following him verbatim, that's fine. Or you can times it by 2 after, and you keep both numbers. But it's 8.84. This one is 8.84, so 1/2 absolute value, because it's a positive distance, 8.84 squared.
Wait, sorry, why aren't you using the 17 seconds again?
Because that's the total time of flight. And Yeah, got it. And this dy, it's not the dy over here. It's half of its motion. The highest point is half.
Okay.
Yes. So whatever that number is, we can calculate it later, but dx, what is that? It should be, it's times vx times t times, so what is it? It's be 50 times 8.84. Nope, wrong, right? Why? Because you need to use the total distance now. The total dx is not this 8.84. That's only here. That would be this portion here, but we want the whole thing. We want all the way. And remember, this is half. So you have to times it by 2, or the original time of flight, however you want to think about that. 17.68. Okay, so 4.9 times 8.84 squared. So then you should have gotten the maximum height, 283. And for this one, the total distance it traveled, or the range, 884. Both in meters, of course. Do you have any questions?
No, that makes sense.
Okay, good. Tell yourself tonight, if you look at it again, or tomorrow before you just glance at it, the process, you're going to be given those two things. Do your best with your picture, but it's really more important to realize what these times are. Okay.
Okay.
This is the first thing you do. Use your equation here. Identify that you're going to the top of your trajectory here. That's why that's 0. Or just call it 0 and call it good. But remember that this time is not the total time for the whole thing. It's only the time to get to half, the highest point.
Okay.
And then you multiply by 2. Why? Because this is, if this is half, well, that means do double it to get the total. That's why we double it. That's why that's the time of flight, means from start all the way to the ground till it hits the ground again. And then being very careful with which time to use. Use the half for the dy and use your time of flight for the x. Summarize there.
Okay.
Okay. Question? Now's your chance.
I don't think so. I think I'm good.
Good. I'm glad to hear that. Sorry for the confusion earlier, but
Oh no, it's okay.
okay. Yeah. Good luck. You're gonna do great. Do your things. You know what I mean? Get your sleep.
Thank
Do
you.
the right things. All right.
Yes, I will.
All right. That sounds good. Have a good weekend.
Okay, thank you. You too.
Bye.
Bye.